Hello everyone, welcome to another lecture of PTR 2131, and today we'll actually cover the topic 4. Now in the previous topic we have learned on the loss of containment. There's lots of new thing we have actually learned, especially what is risk and how we quantify the risk and all other what is a layer of protection, etc. Um, Now, in this lecture, we'll actually learn about the petroleum properties. What you will actually find, knowing about the petroleum properties are very important to assess the risk. At first, you have to know what are the properties of the petroleum, and later on, we will actually know how these properties actually influence to the oil spill and the oil spill preparedness, and also taking the mitigative actions like the control, and all these are actually connected with the loss of containment. We'll see at the later sections, later topics of our course. Okay, so let's learn about the properties of the petroleum. So this is a very important one, because when we will actually do the modeling, especially the spill modeling. So the spill modeling at two parts. One is just think about like the previous lecture, that the loss of containment, we know there are two different parts. Was the um, one is the probability of the failure, or POF, probability of failure. Okay, another is the consequence. Okay, so when we do the spill modeling, we actually learn about the consequence. We actually want to know what is the consequence of a failure. Now the probabilities failure totally depends on as you know, on different things, how it can actually fail, or like the failure things, there are so many modes and options of determining the probability. But the consequence is something that is like after any spillage happen, what would be the consequence. Okay, so these properties of the petroleum actually give us more idea on the consequence. Okay, consequence of the spillage of the petroleum. So let's learn more about it. Okay, so the types of pollutant. So as you can see, this picture actually shows if there is a spillage, how the spill actually covers. Okay, now how it actually spent, why it just don't constrain in one area, why it actually spread, and how fast it actually spread. Okay, so these will actually learn. All right, so this is how this petroleum actually look like, the spill actually look like. For the light crude oil, it looks like a rainbow sheen. Okay, it indicates it's a lighter fraction. But the heavier, it will not look like a sheen, the heavier look like a dark. And in some cases, actually the heavier petroleums, it actually go down, okay, under the water. So these are the things we'll actually know. Properties, the composition, as you know, like the crude oil, it's a generic term for the mixture of different hydrocarbons, right? It's a generic term of the mixture. There are lots of different types of hydrocarbons in here. It's from C1 to C20, and also the aromatics. Okay, aromatics plus different other types of hydrocarbons in there. So these all contains the crude oil, right? So the composition actually varies, each type of crude oil, and each has certain unique characteristics and the properties also. Okay, so these properties influence how material behave when it's spilled, the effect of oil on living organism, efficiency of cleanup operation. Okay, so this property influence mainly these three things, and except for these, we also have to deal specifically with the crude oil and the petroleum products, petroleum derived products. Okay, I mean every single time. Now, the crude oil, there are several different components. Okay, so one of the components are we can actually, categorize in two different ways, or like the VOCs and non-VOCs. VOC means volatile organic compounds. That means which are volatile. Okay, so the hydrocarbon compounds ranging from smaller volatile organic compounds or VOCs to a very large with non-VOCs. That means smaller hydrocarbon, we call it VOCs. Okay, so VOCs have high vapor pressure, low, medium or to medium water solubility, and lower molecular weights. But the non-VOCs got low vapor pressure and higher molecular weight. Okay, so remember these truths. Like VOCs got high vapor pressure, but non-VOCs got low vapor pressure. All right, and usually the VOCs molecular weights are lower than the non-VOCs. Okay, crude oil, as I said, like this crude oil, it got large components. So what are the components crude oil actually can have? So this is an example. Okay, so this is a fractional distillation column, and from there we can actually imagine what are the types of compounds we have. We get gas, C1 to C4, we get gasoline, C5, C6, naphtha, C6 to C10, kerosene, C10 to C16, diesel, C16 to C20, lube oil, C20 to C30, and fuel oil, C30 to C40. Okay, and the paraffin is like C40 to C50. C means like carbon chain, as you know, and bitumen is C50 and upwards. Okay, so we got a wide range of compounds in crude oil. Okay, depending on the type of crude oil. For instance, in the Canadian crude oils, the bitumen content is very high. That means like it's more um, it's more heavier. But the Saudi Arabian crude oil, for instance, or like any Middle Eastern crude oil, those are like, I mean, lighter portion. Okay, examples: the gasoline or the diesel fuel or jet fuel, the mixture of few other compounds. Okay, so these are like, I mean, the rate variables. Right, now characters of hydrocarbon depend on the structures. So let's talk about the saturates at first. The saturate means the compounds of hydrogen and carbon and the maximum number of hydrogen and hydrogen atoms and the carbon. That means it is the single bonded carbon with the hydrogens. Okay, so these are saturated. For instance, alkanes, butane, hexane. Okay, with a longer chain. Okay, those we called actually the saturates. All right. Now the cycloalkanes, cyclohexane, naphthenes. Okay, like this. Okay, this could be the saturates too. All right. So the large structural compounds are often referred as the wax. Unsaturated means it got double or the triple bonds. Okay, it contains less hydrogen atoms than the maximum possible. All right. So these are the unsaturated. Sometimes we actually call these olefins. Okay. So significant amount of olefins found in the refined products. Aromatic. So aromatic, probably we know a lot about aromatic. So benzene is an example of aromatic ring. So what is aromatic? Aromatic means like smells, like smell something like aroma. Okay, it came from this Latin word, like because it got a noticeable smell. Okay, so the aromatic, there the electron actually moves inside, like the rotate. There's the electron cloud inside. Okay, so it contains at least one benzene ring. Okay, those double carbon or carbon rings also could be, like for instance, like there's a benzene ring, and you can have, like, I mean, it can be the take like the toluene, xylene, or I mean, ethyl benzene. So there are lots of other types of aromatic groups are in here. Okay, polar compounds, there are significant, I mean, molecular change. I mean, for instance, if you have the ketones, okay, so, or like, I mean, any other, like, I mean, sulfide, or with the nitrogen. So these we call actually the polar compound, and there are small amount of, like, I mean, the resins. Resin is a type of polar compound, of course, but the asphaltene, there is a large polar. Okay, like the significant portion of the asphalts actually made it the asphaltenes. Um, if there is more polar compound in the oil, will have significant effect in the oil behavior. Now this is an arbitrary sample of, like, the composition would be. I mean, it's not strict, but there is a arbitrary types of the composition. Okay, so remember that. So it's a typical composition of some oil and petroleum products. For instance, like saturates. So in gasoline, diesel, okay, heavy crude oil, we got 20 to 80, okay, whereas the olefins in heavy crude oil would be 0 to 10, okay, or the or like sulfur could be 0 to 5, okay. So it's a typical composition actually, like this. Now gasoline in marine environment, the types of petroleum product we have, for instance, the gasoline. We use gasoline in automobiles or RVs, okay, recreational vessels. Diesel fuel, the trucks, trains, and buses we run with diesel fuel. We have the light crude oil, we get the heavy crude oil, we get the intermediate fuel or IFO that's used in ship, like large ship. Okay, the bunker fuel is a heavy residual fuel remaining after the production of gasoline and diesel fuel refineries, and often is also used at the heating plant. So all these types of oils can be found in the marine environment. There is exposure, the chance of exposure of all these types of oils in the marine environment. Okay. Now the gases we got, like C1 to C4. Okay, methane, ethane, propane, and butane. Petroleum, I mean the liquid at the room temperature, is like C5 to C20. Okay, from the, like, light crude, I mean, sorry, the light oil, like the gasoline blend, or like the kerosene or the lubricating oil. Okay, now the solid at the room temperature, we got like C19 to C50 actually. Okay, so these are all these things, like, I mean, 19 and 20 we got like paraffin, wax, tar, asphaltene, bitumen, and C32 vaselines, and C50 like the, I mean, higher degree of so this is a chromatograph of light crude oil. Now what is chromatograph? Chromatograph is like a fingerprint. You know the fingerprint. Okay, so it is the human index finger, and we got the fingerprint. So what is fingerprint? Fingerprint is something that is actually shows exactly what you are. Chromatograph is something like that. Chromatograph is like, you have a mixture, and in the mixture, what are the components you actually got? So that's actually given by this chromatogram. Okay, for instance, this is a chromatogram of a light crude oil. So here you'll see the maximum portion of the crudes are, like, I mean, the lighter components. Okay, these are the, like, the lighter components. We got the maximum portions, and we got less heavier portions. Okay, so it often used for the fingerprint of the oil, especially tracing the spill. sources. Okay, now this is a chromogram for the Deepwater Horizon incident. Okay, I guess everyone knows about the incident. So it shows, like, I mean, what is the composition of the crude oil was in there. So there's a the red portion actually shows, like, I mean, from the methane to the smaller chains. Okay, so this portion was in the deep plume. That means the partitions was between the deep plume and there's the atmosphere which actually out. Okay, so it was like the medium range here, as you can see. Okay, the medium range, and slick surface slick, like the heavier portion. Okay, so this portion is in the heavier portion. So this is the medium concentration in here, went out at the top of the atmosphere. The deep plume, it was the lightest one. Okay, it just spilled and it got higher volatility, so it can just go out. But this surface leak, it can go under the ocean and deposit in there. We'll actually learn more about these things. So let's learn about the properties of the oil, and that's how we can actually learn, like, I mean, how these actually how we actually categorize these items. The first is the viscosity. So what is the viscosity? Viscosity is the resistance of the flow in a liquid. Okay, the lower the viscosity, the more readily the liquid will flow. All right, so please watch this video to, I mean, learn more on viscosity. Just remember, like, the honey is more viscous than water. Water is less viscous than honey, right? This makes sense. Like, for instance, crude oil is more viscous than water, although the density of the crude oil is higher than the water, and the density of honey is higher than the water. So the density don't have, sometimes don't have direct relationship with the viscosity also. Okay, remember that. So lower viscosity means good flow, like gasoline. Higher viscosity means poor flow, like bunker. Okay, so viscosity is determined by the amount of lighter and heavier fraction. So the more lighter fraction you got, less viscosity. The more heavier portion you got, higher viscosity, right? Now, viscosity is related with temperature. That means that high temperature is the low viscosity. Okay, if you heat up the honey a little bit more, then you will find it moves better. Okay, so this is the lower viscosity, and in low temperature it becomes high viscosity. If you actually freeze the honey, you'll find the viscosity actually increase more, right? So the higher viscosity liquid doesn't spread rapidly. Remember that the high viscosity liquid doesn't spread rapidly. It does not penetrate soil rapidly. It the effect of ability of pumps and skimmer. Okay, we'll actually learn later what are the pumps and skimmers. So viscosity, like, that's the unit is Pascal MPSA. Okay, at 15 degrees Celsius. What are the typical viscosities? Gasoline 0.5, diesel 2, light crude 5 to 50, and you can see the bunker is 10,000 to 15,000. That means the gasoline is way less viscous than the bunker fuel, right? Or like even the heavy crude oil. Just check the heavy crude oil. The range is huge. It's like from 50 to 50,000. It's massive. Okay, so viscosity is a very important factor we got to remember. Okay, now it comes to the density. What is density? Density is the mass the given volume, or gram per centimeter, or kg per meter cube, or pound by cubic feet, right? So there are different heights, I mean different units actually we can measure the density. Now it indicates whether the oil will sink or float. For instance, the water density is 1. However, the seawater is a slightly higher. It could be 1.02 to 1.1. It depends. It totally depends. Okay. I mean, oh, sorry, 1.05. Like On an average we'll actually get 1.03. Okay, oil is 0.7 to 0.99. Okay, so it seems like since oil is lighter than the water, especially the seawater, so it should actually flow. But there are some exceptions. We'll actually learn those exceptions later. Okay, so the density of spill oil increase with time on a few occasions. For instance, bunker oil. Okay, the density is higher, as you can see, 1.04. So what happened if bunker oil spills? It will go under, right? So the density of oil increase with time as a lighter fraction evaporates. It's a very important statement. Remember that. How it actually works. For instance, you had a spill. Okay, this is the water surface. You have a spill. The more time will go, then what happened? The more vaporization will happen. And when the lighter components will go out, only the left would be the heavier components. Okay, so that's why it says the density of oil increases with the time the lighter fractions evaporate. Okay, so this is the typical density: the gasoline, diesel, heavy crude oil, IFO, bunker oil. Okay, now emulsification process. Emulsions are a process where one liquid is dispersed into the another liquid and form a small droplets. That means this is not uh, I mean they do not react, however, but they emulsified. Okay, for instance, what is the paint is an example of the emulsification. Okay, so water and oil, they don't mix with each other, but however they can make an emulsification. Okay, now why it is bad? Because it consists it looks like a chocolate mousse. It's high in viscosity and density. It's a challenging in cleaning up. Okay, you have to remember that. This is how the emulsification actually looks like. It's very dense, thick, like a slug, and it's really hard to actually remove. Okay, so that's the thing. Specific gravity. Now, specific gravity is a way of expressing the density. Okay, a measure of density is a specific gravity, which is oil relative density compared with the water at 50 degrees Celsius. Okay, now API develop a special scale to measure the gravity, specific gravity. Okay, so that's we called API gravity. It's a different type of scale. Okay, how the scale actually works? The formula is 1 for 1.5 divided by the density of that component at 15.5 degrees Celsius minus 131.5, and it gives the this is not the density. I mean, the density would be like 0.95 or something like that. So when we actually put in there, then we will find the API density. Now here is the interesting thing. The API density, or we call the API gravity, the higher the API gravity means the lower the specific gravity. Okay, look at the formula. It's inversely proportionate. Okay, so that means the gasoline's API gravity is 65. That means it's lighter than the bunker C, which is 5 to 15. Remember that. Okay, this is very important. So this is the API and this is the specific gravity, and these are inversely related. Okay, solubility. Solubility in water is a measure of how much of an oil will dissolve in water column on a molecular basis. The loss through solubility is low, is like less than 100 ppm. Okay, so the evaporation is a bigger source in the loss. So the solubility of gasoline is like 200 ppm, and the solubility of bunker oil is 1 to 5 ppm. What does that mean? That means a very small fraction of oil can soluble in water. So the more lighter the oil is, the more soluble it is, the less, the heavier the oil, the less likely it will be soluble. Okay, so this how it actually solid, it actually creates the crude emulsification. Look at this picture, we can see the dead fish, and that's why I said, like, this emulsification is very bad, because it actually create a film on the top, and that what's happened, the fish, the oxygen cannot actually get through the water, and the fish cannot breathe, and that's one of the reason there will be lots of aquatic diversity, the aquatic creations would have some creatures would have the problem with this crude emulsification. Okay, so this is very, very bad. Now the solubility, this is a chart. So the gasoline and the heavy crude oil, as you can see, the more, the heavier the component, the less the solubility. Okay. Flashpoint. Flashpoint is the temperature at which the liquid gives sufficient vapor to ignite the exposure to an open. Okay, for instance, the flame it is considered to be flammable if the flash point is less than 60 degrees Celsius, because in some occasion, the temperature could go beyond 60 degrees Celsius. Then there could be an auto ignition. Okay, the gasoline flammable under all condition when it is spilled. So this is very, very dangerous. For instance, there is the oil spill, and if there is a spark, by anyhow there's a spark happen, so there could be lead a disaster. Okay, so the crude oil may be flammable until the VOC evaporate. Okay, after the VOC evaporates, then the most flammable part would be gone. After that, there will be the only the thick and sluggish portion will be present only, and that could not be flammable, and the flash point could be higher, so that is more safer. But until the components has been evaporating, it could be very dangerous. Okay, so the bunker C and heavy crude oil generally not flammable, as it makes sense because it got higher hydrocarbon chain. Okay, that means lower uh, evaporation, and that means less flammable, so the flash point would be very high. So the typical examples, like the gasoline's flash point is minus 35, whereas diesel is 45 degrees Celsius. So that means that gasoline is way, way more dangerous. For instance, light crude or heavy crude oil, the range is really wide, like minus 30 to 30, or for heavy crude oil minus 30 to 60. So we have to care, concern about the flash point of the oil that spilled. Pour point is the temperature at which it takes longer than specified time to pour from standard measuring vessel. That means how liquid, like how the first pouring the liquid. Okay, that means it's a result of a combination of the most of the other properties. Pour point has been used too much in the past to predict how oil will behave in the environment. The very simple example is a butter. Okay, for instance, you have a chunk of butter in the on your pan, and you are actually heating up. Okay, at a certain point, if your container is like this and the butter is like here, and you are actually heating up with the temperature, at a certain point you will find there is the butter is melting and going out. Okay, so that temperature, for instance, this is a for instance, this is actually happen at 15 degrees Celsius. So that would be the pour point of the butter. Okay, so why this is important? Because at the pour point, we can actually predict how it will behave in the environment. So for instance, if the butter spilled, okay, at which temperature it will actually liquid. Okay, these are the pour points of different For instance, light crude is minus 40 to 30, heavy crude is the same. Gasoline don't have any pour point because it's vaporized, but for the diesels, as you can see, this is the pour point. But for bunker fuel, it's mostly like solid type, so the pour point will be range from 5 to 20 degrees Celsius. Okay. Fractional distillation. Well, as you know, the crude actually have lots of different types of a mixture, like from C1 to C35, even like some crude got C50. Okay, so all these actually we need to I mean, when you need to separate, then what is done, like it represents the fraction of the oil boiled off at a specific temperature. Okay, this data is used by refineries so that they can adjust their refining parameters to handle the oil. So the 70% of the gasoline would be boiled off at 100 degrees Celsius. The more temperature you will actually increase, the more would be the heavier component we'll actually get. Okay, so the gas at 20 degree, petrol 70, and the naphtha 120, kerosene 170, diesel 270, and the more higher like 350 up, or like sorry 340 up, will actually cut the portions in here. That's how we actually separate in the crude oil. Okay, so these are the distillation fractions usually we got in the crude oil. So why this is important? Because from here we can actually learn, like, what fraction could have in the crude oils. Okay, surface tension, a very important part. What is surface tension? Surface tension is the force of attraction or the repulsion between the surface molecule, the oil and water. Okay, the surface tension is a result of intermolecular attraction between the molecules. Lower the surface tensions means greater the spreading. It makes sense, right? So if, for instance, this is the sea or the ocean, this is a tanker, and this tanker actually spilled some oil. Now, if the surface tension is lower, then it would spread more. But if the surface tension is higher, it will spread less. Okay. So in practice, the interfacial tension must be considered with the viscosity to account the spreading behavior. That means for more viscous fluid, the surface tension is more higher, so it will spread less. Less viscous fluid, the surface tension is lower and it will spread even more. Okay, so these are all explained in here. Please read this slide. Is very important, very important. Okay, very important one. Surface tension got lots of factors. The factors, it can actually factors with the wind and current. We'll actually see in detail when we do the spill modeling. Okay, how the surface or like the interfacial tension affect with the wind and current. Okay, the spreading could be caused by the force of gravity. How it actually works, we'll also see that. It's very important part. Okay, so the interfacial tension between all these fluids actually explained in here. Okay, vapor pressure. Finally, so what is the vapor pressure? Vapor pressure means it measures how oil partitions between the liquid and gas phase, or how much vapor is in the space and above given amount of liquid oil at the fixed temperature. Okay, so the vapor pressure change the oil weather. Okay, it's affect the weathering. If the VOC have higher, the VOCs usually have the volatile organic compounds have the higher vapor pressure, used more with spill into the soil. Now, why VOCs have higher vapor pressure? At the live session, I will actually ask this question to all of you. Okay, why VOC could have higher vapor pressure, and what is actually the vapor pressure? That's your task to learn. Okay, so this is it about today's lecture. We have learned about the different properties of the hydrocarbons. Please go through the slides very carefully and learn even more, and go to the references. you will have better understanding and better idea about the properties of petroleum, which is a very important part of our course too. Okay, all right. Have a good one, and see you at the live lecture class. Okay, bye.